What's going on, guys? Let's look at this problem right here. Here this question is asking, what is the minimum value of RB that guarantees operation in the active mode? And the B part is asking, with the value found in RB, how much base collector forward bias is sustained in beta rises to 200? Okay, now let's look at the first problem. What is the minimum value of RB that guarantees operation in the active mode? First we have to know the active mode condition. I'm doing the A part. Active mode condition is VCE has to be greater than or equal to VBE. If this is the active mode condition. Now instead of VCE, we can replace VCE with VCC minus IC times RC. In our case, RC is 2 kilo ohm. I place it right here, 2 kilo ohm, and that one should be greater than VB. Instead of VB, we can put VT ln of IC over IS. Okay, now VCC is here, 2.5 voltage, 2.5 voltage minus IC is not provided, so I keep it as it is, 2 kilo ohm, and that is greater than or equal to VT. VT is a constant value, that is 26 millivoltage. Ln IC is IC, and IS is 6 times 10 to the power of minus 16 for the active mode. Now here we are going to solve for IC. IC is less than or equal to 8.56 ampere, 8.66 ampere, microampere. Okay, now we found out the IC. Now the next thing is we are going to solve for RB. That's the question. Let's continue it right here. Here VCC minus VBE over RB. If we apply KCL, that's equal, that's minus VBE. This, but the current we found out is IC, and if we apply KCL around this one, we will get VC minus VBE over RE, then minus VB over 3 kilo ohm. That is equivalent to the base current IB, and instead of IB we can replace it with IC over beta. Okay, VCC minus VBE, and instead of VBE we can replace it with VT ln of IC over IS over RB minus this one is VBE. Instead of VB, again we can replace it with VT ln of IC over IS divided by 3 kilo ohm. That's equal to IC over beta. Here our purpose is to solve for RB, and if we rearrange this one in terms of RB, we will get RB is equal to VCC minus VT ln of IC over IS divided by IC over beta plus VT ln of IC over IS divided by 3 kilo ohm. Okay, now let's go ahead and plug the values. VCC is 2.5 voltage, minus VT is 26 millivoltage, ln of 8.66 microampere. I made a mistake right here. It's 866 microampere. This one is 866 microampere divided by 6 times 10 to the power of minus 16, 6 times 10 to the power of minus 16 ampere divided by IC over beta. IC is 866 microampere divided by 100 plus Vt is 26 millivoltage times ln of 866 microampere divided by 6 times 10 to the power of minus 16 divided by 3 kilo ohm, and that gives us Rb. Okay, and Rb is greater than or equal to 7.04 kilo ohm, and that's our base resistance. Now we are going to do the B part. Let's get rid of this. We are going to do the B part. B part is asking with the value found in Rb, how much base collector forward bias is sustained if beta rises to 200. Okay, here again the same case here. VCC minus VBE is equal to Rb minus VBE over 3 kilo ohm is equal to IB, and this one also is equal to IC over beta. And if we rearrange this one, everything in terms of IC, we are going to have, because IC over beta is this whole thing, if we rearrange this one in terms of IC, we just have to multiply everything by beta. So this is going to be beta times VCC minus VT ln of IC over IS divided by Rb minus beta Vt ln of IC over IS divided by 3 kilo ohm resistor. Now let's go ahead and plug the values. 200 times 2.5 voltage minus 26 millivoltage ln of IC over IS is 6 times 10 to the power of minus 16 divided by Rb, that is 7.04 kilo ohm, minus 100 times 26 millivoltage ln of IC over 6 times 10 to the power of minus 16 ampere divided by 3 kilo ohm, and that gives us 1.14 milliampere. And this is IC current, but here we are asked to find out the voltage VBC. VB is equal to Vt ln of IC over IS, and this gives us Vt is 26 millivoltage ln of 1.14 milliampere divided by 6 times 10 to the power of minus 16 ampere, and that gives us 755 millivoltage. But we want to find out the VBC. VBC is equivalent to VBE minus VCE. VBE is 755 millivoltage minus, okay, Alexa, what is 26 ln of 1.14 over 6?
Sorry, I'm not sure about that.
Okay, I made a mistake in this calculations. This one is 735. Millivoltage minus 215 millivoltage, and that gives us 520 millivoltage, and that is VBC. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.